Every company that has a large set of customers has a large set of data, whether that company is 5 years old or 50 years old. That data is valuable whether you're an insurance company, a soft drink manufacturer, or a ride-sharing company. All of these large companies know that their data is valuable, but some of them are not sure how to standardize the access patterns of that data or how to build a culture around data. The larger the company is, the more data is spread throughout the company, and the more heterogeneous the data sources are. Older companies often have older pieces of data infrastructure, and it might not be well documented. It is hard to make data-driven decisions when an organization cannot effectively query their own data. For example, consider a simple question about marketing. An insurance company wants to know how their spending on TV advertising correlates with sales in California over the last 25 years. Imagine that question. How do you correlate marketing at an insurance company through TV advertising with sales in California? Historically, you might have just used your gut intuition, but today we should be able to do some kind of data-driven analysis. And we do try to do data-driven analysis. Perhaps the VP of marketing sends an email to a business analyst within the company and asks for a historical report of marketing data. Then the business analyst can know how to present the data with a business intelligence tool. But the analyst first needs to ask a data scientist how to make that query. The data scientist needs to ask the data engineer where to find these records in a large Hadoop distributed file system cluster. And the data engineer might have just joined the company last week and might not have any idea where anything is. These are the problems of DataOps. Similarly to DevOps, DataOps is the recognition that a set of problems have crept into organizations over time and slowed down productivity around data. The story of the DevOps movement is that old infrastructure, lack of testing, and complicated monolithic backends slowed down everyone in an old, big enterprise. The slow pace of change destroys morale and erodes trust. The DevOps movement is about revamping organizations through tooling and organizational behavior. We've covered this in lots of episodes, such as in a great episode with Gene Kim, who wrote The Phoenix Project. When an organization wants to reinvent itself with DevOps, it often begins with testing and continuous delivery. DataOps encourages data-driven organizations to begin with a similar practice of testing their data pipelines to build trust and evolve best practices. There are other similarities between DataOps and DevOps, such as continuous delivery and the breaking down of silos between different organizational roles. Chris Bergh joins the show to talk about the data problems encountered by large companies and the practices of DataOps, as well as his own company, Data Kitchen, which builds tools to help companies move towards more productive data practices. Citus Data can scale your Postgres database horizontally. For many of you, your Postgres database is the heart of your application. You chose Postgres because you trust it. After all, Postgres is battle-tested, trustworthy database software. But are you spending more and more time dealing with scalability issues? Citus distributes your data and your queries across multiple nodes. Are your queries getting slow? Citus can parallelize your SQL queries across multiple nodes, dramatically speeding them up and giving you much lower latency. Are you worried about hitting the limits of single-node Postgres and not being able to grow your app? Or having to spend your time on database infrastructure instead of creating new features for your application? Available as open source, as a database as a service, and as enterprise software, Citus makes it simple to shard Postgres. Go to citusdata.com/sedaily to learn more about how Citus transforms Postgres into a distributed database. That's citusdata.com/sedaily, citusdata.com/sedaily. Get back the time that you're spending on database operations. Companies like Algolia, Prosperworks, and Cisco are all using Citus, so they no longer have to worry about scaling their database. Try it yourself at citusdata.com/sedaily. That's citusdata.com/sedaily. Thank you to Citus Data for being a sponsor of Software Engineering Daily. Chris Bergh, you are the founder of Data Kitchen. Welcome to Software Engineering Daily.
Thank you for having me.
Data analysts and data engineers are often working to answer requests of higher level business people, like a VP of marketing or somebody else that's higher up in the organization. And you often get a waterfall down of a higher level business request, like somebody at Uber might say, I want to know how many rides took place on July 4th. And then that translates into work at the data analyst level, perhaps the data engineering level. What are the challenges in the interactions between these different layers of people, the higher level business person, the data engineer, and the data team?
There's kind of two categories of challenges. So one is, I have a software engineering background and a data science and AI background. So I'm going to kind of bounce back and forth between those perspectives. So the first challenge, I think, is that, like you said, data analytics is really a kind of a search and find, maybe a science, maybe it's a random walk through. You have all these data sets and all these ways to visualize or segment or group or run algorithms on, and you're really searching for a needle in a haystack and then trying to take that needle in a haystack and institutionalize it in some process. And so that's really the challenge, is both finding it, and there's just a lot of great tools and methods to sift and winnow data. And so that's one challenge. And then the second is once you have that insight, how do you actually turn that into kind of a low cost, high quality, ongoing deliverable? And so those are two from there's a cousin team to a software engineering team. Sometimes it's under a chief data officer or a chief analytic officer or a head of data science. And there's different roles in that team, like you suggested, data engineers, data scientists, people who do visualization. And so, I think those teams have a lot to learn from software and software engineering, but they also have just their unique set of challenges that, that's something that we're trying to do as a company, and I'd like to talk about today.
There are different tools that each of these different organizational players putting into practice. So at the VP of marketing level, they're maybe using Tableau or Excel or other visualization tools. The data engineer is maybe using Airflow and Redshift and a variety of other things. Data analysts and data scientists are using different things. What's the pipeline of these different tools, and how do they connect to one another? How are they sharing data between the different sections of the pipeline?
Well, it's complicated, right? Because there's, the person at the end of it, the person who's receiving value, and maybe it's a customer on your website, or maybe it's a business user. They don't care about the tool chain behind it, right? That they just want the insight, and they want to trust that the data is right. And so you've got this diverse set of tools, and there's, if you look at the people who do visualization, there's like 50 companies. Tableau's the most famous. People who do data science, there's R and Python, and then a whole bunch of other people do it. And then, there's 50 companies that do data engineering and ETL. And there's a complicated tool chain out there that people use. And one of the challenges that your business customer sees is they don't see the tool chain, and they don't see that some things there's always a discontinuity, even when you're building software or building analytics. Some things are easy and some things are hard. And if you look at it from the perspective of your customer, they can't see that discontinuity. They can see, I want to have a segmentation, or I want to know more about my customer. So that's really the challenge. So how do you have all those tools? And my perspective on it is, I worked at a company before I founded Data Kitchen, and we tried to do everything in analytics, data engineering, data science, visualization in one metadata-driven platform. And, it started in 2005, and maybe we were all kind of diluted at it, but, sort of pour in metadata, pour in actual data, and get out this challenge, right? Because as a technologist, you kind of see what happens behind the curtain, and you see that some things take long and some things take short, and there's these weird discontinuities. And so when you talk to a business user, they don't see those discontinuities. They just sort of expect things to be right and to work. And there's a sort of diversity of tools that each individual contributor uses in analytics. And, there's 50 different BI tools, 50 different data science tools, or tools to make data science easier, and probably 100 different tools to transform data and do something with it. And everyone loves their tools. And I had a hard lesson starting in 2005 at my previous company. We tried to build sort of the tool that did everything and analytics, sort of pour in metadata and get out visualizations and data transforms and some models. And, that sort of got 80% there. And then you climbed the asymptotic wall of hardness and we ended up putting bags on the side. It just didn't work, right? And so it worked partly. And so I fundamentally believe that people who do the work love their tools, and the people who receive the work, first of all, have a hard time knowing what they want. And then once they get what they want, they don't ever want it to break and want to have supreme confidence in the results.
So I think this gets us closer to the discussion of that DataOps term that I've heard you talk about in other places and also on some videos. So I think DevOps is a widely used term, and I think that what DevOps was trying to encapsulate or is trying to encapsulate is that there's a variety of practices that are all connected to one another, and it's hard to say exactly how they are connected, but there is containerization, there's the rise of continuous delivery, there's the rise of people being able to communicate more fluidly in Slack channels, which leads to breaking down communication silos more easily, which is why development and operations, these two terms that used to be discrete, got sandwiched together, where you now have developers and operations teams that can work more synergistically, they can overlap with one another. And my intuition is you're kind of saying the same thing with DataOps, where DataOps is a representation of you're trying to break down some of the silos, you're trying to make some of the tools play more nicely together, you're trying to let some of the communication barriers between different sections in this data pipeline break down a little bit. Help me get an intuition for what you're trying to get at with DataOps.
Oh, that's really good, actually. You said it very well. At a really high level. So, I've had part of my career being in software engineering and part of my career being in the data and analytics world. And they're kind of cousins to each other, but they're different planets in a lot of ways. And all those terms you said about Agile and DevOps and infrastructure as code and getting development and operations together and all those, even things like source control and branching, there's very few people actually in the analytics world, and it's increasing, who are familiar with those terms. And for the last 5 years, we've been going out and kind of evangelizing these sort of DevOps-y, agile, lean manufacturing, statistical process control based ideas in conferences. And 5 years ago, I'd raise my hand and ask who knew about source control, and to people who've been in the analytics field for anywhere from 2 years to 25 years. And a couple percent knew what they were. And in general, the software world and the data and analytics world, they're like each other, but they're different. And so there's this different culture and different attitude about how people work. It's kind of similar to when I was a software engineer in the 90s, and you had teams that were stuck in kind of this mode of either being heroes, where they were just, I wrote all the code, I'm going to maintain the code, I wrote some tests, maybe not, and if something breaks, I'm going to go run and fix it because, I want to look awesome. Or they get in the other way where they're so afraid to do things, they have these giant, long waterfall processes and manual QA things, and it takes them 6 months to ship everything. And I think what the software industry is learning and continually learning is that at the highest level, it's pretty hard to know what your customer wants. And writing, I've done the role of product manager, I've managed product management teams, and writing long requirements documents, reviewing those with customers. It's just so much easier to put something in a customer's hands and get their reaction to it, and then iterate and improve. And so that is I think just a much better way to work for a lot of reasons. And some people call it Agile, some people call it DevOps. They're like, in the tech world, there's just a bunch of terms for different things. But to me, it's about how to force feedback into your team and not how to get caught in either fear or heroism on how they work. And so we're trying to bring those ideas that are based in software, but also based even before that in, I grew up in the 80s in Wisconsin, and actually Milwaukee, Wisconsin in the early 80s, had its industry sort of taken out. 50,000 jobs were lost in the early 80s in Wisconsin, mainly from Japanese imports, because they were making better cars, better small engines, because they had adopted ideas of just-in-time inventory, statistical process control, and this crazy guy Deming, who had looks like his ideas about how you should run a factory floor automation and how you could produce things of high quality are really, I think, important. And I took those to heart kind of about 15 years ago. And I think when you do analytics, you're also in a lot of ways running a factory floor. And so you've got all those, we've a perspective on that in DataOps.
Okay, so you hear this with the DevOps people as well, where they talk about the connection between lean manufacturing and the DevOps movement and kind of some of the procedural, some of the relationship management aspects of a productive assembly line or a productive industrial team working together. How does that relate to DevOps and how does it relate to DataOps?
Yeah, so I look at it from a guy who's done a lot of coding in my life and a guy who's managed a lot of people who've done coding and technical work. And so it's in some ways it's a different challenge when you have a bunch of people. And one of the first things I faced as a manager was the urge to blame. Like something goes wrong and it's really easy as a manager to throw one of your employees under a bus and say it's their fault. And one of the key lessons of Deming is it's actually rarely someone's fault. It's usually the process that person is working in. That's the fault. That's the root cause of the fault. And since you're the manager, you own the process that people work in. So that means when things go wrong, it's almost always your fault, which kind of sucks, honestly, to live with as a manager. But it's actually true. Very rarely do people actually screw you over. Do people actually fail? A lot of times it's you haven't put people in a set of procedures and processes to actually work together or to continuously improve upon what's there. And so that kind of shift in mindset, I think, is true in Deming. It's true in kind of lean manufacturing. It's true in Agile and DevOps, and now it's true in DataOps. Don't blame your employees. It's usually your fault as a manager that you haven't put them in a position to succeed. And so, how do you, as a manager, put your team in a position to succeed? I think if you look at the Agile Manifesto, it was about hyper-empowered individuals using the tools that they love, giving them impact in the customer, having small teams, having small deliverable cycle times in which they can deliver. And then that's great. A lot of people started to do things like Kanban and Agile Scrum. And then they realized, man, I still got to test all this stuff. I still got to deploy all this stuff. And what if I start to automate all that? And that actually, the combination of Agile and DevOps, I think really, and in some ways, DevOps is superseded the way Agile people do DevOps now. And what they mean is I run Scrum, I have short cycle times, but I also automate my deployments. I do continuous integration. I do infrastructure as code. And so those similar set of ideas that came from industrial process control that sort of, in my mind, passed through software engineering, we're trying as a company to bring those into how people do data science or data engineering or even data visualization.
Okay, let's walk through some of those specific ideas. DevOps, for example, when I talk to people in the DevOps movement, there was a while ago where I did a ton of these shows because the DevOps movement was really heating up with Gene Kim and Phoenix Project, and they had these huge insurance companies, for example, that were trying to figure out how to, they found the insurance companies and the, oil analytics companies all found themselves in a situation where all of a sudden we're a software company and we didn't expect it. And so then, they have these huge monolithic applications and these non-software oriented teams where, they wake up one day and they're a software company. They're now a software company that produces insurance rather than an insurance company that happens to have some software in the back office. And the thing that the DevOps people always seem to emphasize is getting testing in place, because the testing is the backbone of the continuous delivery model. Because if you have testing in place over some scope of software, then you can start to do more rapid deployments within that scope of software, because then people have trust. If you have a well-tested piece of software, then you can push out changes more aggressively and have those changes be run through automated tests, and then you feel comfortable deploying it to production or at least some subset of production. Now with DataOps, it is interesting because, machine learning and data science models and things that are more a wider granularity of is it working or not. These things are becoming more and more of our application development, and they seem like they're harder to test because of that wider array of granularity. Like if Uber has a new pricing model that they want to deploy. Is it working or not? Well, I mean, we can create some bounds checks that can test some really naive things, but there's going to be so many edge cases that a machine learning model could spit out, for example, that it's sort of hard to produce a robust set of tests for a machine learning model. But that's not to throw testing, in the garbage at all with the DataOps movement. Tell me about how testing should fit into DataOps and what kinds of tests are we talking about? What kinds of applications? Because obviously, I think we're kind of like data applications. There's a wide array of data applications. There's dashboards, there's machine learning models, there's batch jobs that run every night and deliver you a report. So there's obviously a wide array of things, and testing will apply more to some than to others. But testing really does seem like a cornerstone of what you're trying to go for with DataOps. So tell me more about your vision for testing.
Yeah, those are all good points. And kind of to back it up, so where companies are today, and we talk with large insurance companies, instead of trying to be a software company, they're now trying to, what Gartner says, be a data-driven organization and get value from their data, monetize their data. And so they're trying to see themselves as a Facebook or a Google, not in the sense that they write code, but in the sense that they've got this stream of data that they're trying to turn into value. And so that is what the chief data officers, chief analytic officers talk about. And so in order to do that, they have, in the world of analytics, I believe similarly to DevOps, that testing is important. And tests have I do believe that you can test everything, including predictive models. And tests have kind of a duality in how people run. So that there's this manufacturing line where if you imagine data's on the left and a bunch of tools glom onto that data that maybe it's Airflow that does the data organization. Maybe you've got a Python model running. Maybe it's showing up in Tableau. And there's sort of manufacturing happening and data's flowing in from the left and going out on the right. Maybe it streams in. Maybe it's done in a batch cycle of a day or an hour. But really, you have this kind of river of data flowing through your systems and tools acting upon that data. And so you have this, whether you call them tests or operational testing or operational monitoring, you have to understand your factory floor as it's running. And those testing and what I would think of as from a software background as tests is incredibly important there. And it's just amazing to me how many companies don't have any tests or monitors in there. They just change some code, they have some people look at it, and then they throw it up, either because they're heroes or because they haven't taught to it. And we try to guide people to think about, you are running a factory floor. And actually you should, if you want to do statistical process control, you should writing tests, and those tests are actually sensors or monitors. And that's actually a data set that you can use to get very analytic about your process. Because if you look at Toyota's assembly line, they have a huge amount of analytics that they pour off of in terms of yield, in terms of error rates that can help you improve. And even in a simple case, I've managed data engineers who at first they would just do these long builds. Maybe this is in sort of the mid 2000s, take 12 hours to build a database. And they would sort of hope that everything would work out. And after 12 hours, they'd get an error. And then they have to go back, change 4 lines of SQLs and rebuild the whole thing again. Wouldn't it be smart to actually, in an hour in, write a test to that build to see if something's wrong? And that way you can tell and shorten your cycle time to find the errors. And so I think testing from a production standpoint is really important, and it's a really source of value. And you can test anything because it's all code. I mean, a predictive model's code. A visualization, maybe it's configuration, but you can put Python and if then else is in a Tableau model, and certainly the directed graph or SQL that's running or ETL code. It's all code, and so you need to be able to, while it's running, test it. And so that's first idea, is that tests or operational monitoring are really important. You should do it. It should be 20% of your code base. So, but that is only good because it helps you prove that you aren't delivering erroneous data or reducing your errors in front of your customer. Because, in analytics at the highest level, what we're trying to solve is have people use data to make decisions instead of intuition. And it's really easy for people to dismiss the work that a team does to produce data, produce analytics, and just say, my gut says this. I know the data might say this, but I think your data's wrong because you had this error last week. And so you need to run an assembly line of data with all your tools that's instrumented with a lot of tests so you can get your customers to believe what the data says. That's like the first order of business.
stop wasting engineering time and cycles on fixing security holes way too late in the software development lifecycle. Start with a secure foundation before coding starts. ActiveState gives your engineers a way to bake security into your language's runtime. Ensure security and compliance at runtime. A snapshot of information about your application is sent to the ActiveState platform. Package names, versions, and licenses, and the snapshot is sent each time the application is run or a new package is loaded, so that you identify security vulnerabilities and out-of-date packages and restrictive licenses, such as the GPL or the LPGL license, and you identify those things before it becomes a problem. You can get more information at activestate.com/sedaily. You want to make sure that your application is secure and compliant, and ActiveState goes a long way at helping prevent those kinds of troublesome issues from emerging too late in the software development process. So check it out at activestate.com/sedaily if you think you might be having issues with security or compliance. Thank you to ActiveState for being a new sponsor of Software Engineering Daily. So those tests, is that like a test data set? Like if I want to test my new factory floor monitoring system, it seems like my testing would actually be a data set where I would have a data set that would include outliers of certain aspects of behavior. And then I would have, I guess it would be one part data set and then one part some framework around that data set that determines, okay, did the monitoring system actually detect that there was an outlier here? Yes, it's green. And then, we confirm that, and then we move the model forward along the production pipeline, or...
Yeah, the tests kind of have, there's this duality to testing in analytics. In one case, the data's changing, right? Because you're getting new data sets, and if you've ever done analytics, your suppliers of data always give you crap. There's always errors. You're always going to have to go and do data deep dives. You want to find problems in data sooner rather than later. Those things are, if you've ever delivered analytics, are pretty standard. And the tests help you do that. And the tests help you prove that as the data is flowing through the system, that your code's working. And so in one sense, the data's changing, but the code and the tests are fixed. And that helps you produce a accurate deliverable for your customer to believe to do analytics. Now, the other challenge is that at the same time, you've got your Toyota factory floor humming, and those tests are producing analytics for you to manage. Those tests themselves, you should be able to fix the data and then change the code to actually be able to then help deploy new code in production and change the factory floor at the same time. And so, there's this kind of dual nature to it, right? The river of data, changing data, and the tests are monitoring it. And then you take a sample, maybe a sample of the data, a subset of the data, the whole data set, because sometimes, a couple of terabytes of data isn't that big. And you use that to do regression testing, feature testing, performance testing on your code. And really the tests, in a lot of cases, you can reuse a lot of the tests. Some tests are unique to one environment versus the other. But that's where, conceptually, what we're trying to do with DataOps is get people to think that way. Testing's important. Automated testing's important. Don't do it manually. And when you're actually going and have those tests are useful because, hey, if you change code, it's regression, feature, automation. It's just like the stuff we do in software engineering. But you know what? Those same tests, they should monitor your system so no bad data gets by, and then your business customer doesn't think you're an idiot and trust their gut, not what your data team says.
Okay, so this is reflective of DevOps once again, because you're not prescriptively saying you need to do testing in this way. It's more like it's proscriptive. It's don't do testing in the way where you like have a new piece of software and then you like eyeball it for a little while. I mean, in some cases, you eyeballing it is helpful or complementary to automated testing, but get some automation in place, because the more you try to automate things, the better a sense you will get for what should be automated. I mean, you may write some automated tests and you're like, okay, that was not super helpful for me, but it taught me how to do automation, how to put some framework around my data deployment pipeline, whether that's a batch job or a monitoring dashboard that I want to have faith in, or this, safety system that I'm writing for my factory floor, rather than just having these models being deployed willy-nilly and eyeballing it, and then nobody trusts the system, and there's just a low level of trust, and that low level of trust permeates to the whole engineering organization. I'm sure there are places where that happens, and I think testing probably reduces some of that.
Oh, absolutely. Yeah. There's kind of these two pipelines going on, as you mentioned. One is the orchestration of all the pieces and when you're running your factory. And that's one kind of pipeline or directed graph. And then you've got the other kind of pipeline going perpendicular to that, which is kind of the deployment of new code into it. And so you've got to you should be able to do both things simultaneously. And like a characteristic of a test on the top part of the T, where you're just sort of orchestrating all the pieces to manage production, is I've gotten a file that's gotten 1 million rows, and it's come to me every day, and it's got about 1 million rows. And so today I got a file that's got 100,000 rows. Is that an error? Is that a warning? So you should notice it, right? Because your customer may end up saying, what's wrong? All of a sudden, it'll show up in the Tableau dashboard. It'll show up in some weirdness in the predictive model because instead of 1 million rows, you got 100,000 rows. And they'll notice it and call you up and say, what's wrong? And then as a data team, you're like, oh, wow, we didn't notice that. It's much better to notice it, have a flag that says this is statistically out of bounds, and do a number of things. Reject it because it's wrong. Reject the data source. Maybe it's patch the data with yesterday's data, or just put a release note to your customer saying, we noticed that this data dropped. Could you help us figure out why this is? And all those things make you a much better partner to your business person by noticing. And that's captured by a test. It's captured by statistical process control. And really what you're testing on the top part of the T is variability in data. And so you could take that same test that has 100,000 rows, and there's further things that you could do with that 100,000 or 1 million rows. You could be making a dimension in a fact table. You could be running a segmentation model that's supposed to have 10 segments off that dimension. And so if you take and fix the data set, saying, okay, I've got my regression data set that I use for development, I should be getting 10 segments out of my predictive model. And, my dimension should have on the order of 50,000 items in it. And all of a sudden you don't, because you're working in your development box. That's an error. And why is that? Well, maybe it's because the model needs tweaking. Maybe it's because somebody messed up the SQL code. But that's also a use of that same test to help you, when the data is fixed, help you understand that you've broken some code. Because the ideas are really similar, right? You want to be able to have, one of the tests is, can you take someone who's 2 years out of college, and can they make a change to your complicated data system and deploy it into production, and you're not going to worry about it? And you're not going to have a change review board, or you're going to, you should have things like code reviews. But a lot of companies, they put this huge amount of process in and analytics. And it literally, there's insurance companies we work with, it literally takes them 6 months to update the code in their data warehouse. And that's just that's insane. Because they're so afraid of making data errors, because in order to do that 6 months, they've got to have the people who know the system, know all the history, have the whole system in their head, give it their blessing. And that all comes from a lack of automation, both in terms of testing automation, deployment automation, regression testing, and the stuff that the more refined word of DevOps talks about. Can you have your development environment be reflective of your production environment in terms of servers, infrastructures, libraries, et cetera?
That's chilling to think about the 6-month turnaround time for a code change at a large, kind of non-historically technology company, like a large insurance company. It doesn't really surprise me. Can you tell me more about your experiences with customers? I mean, we could talk a lot about DataOps. I find this whole conversation topic very interesting, and the ideas of DataOps, like version control and the same things in DevOps, containerization, infrastructure as code, etc. But take me inside the world of the customer, because you're actually working with some of these companies that are trying to implement DataOps, specifically through your tooling that you've built, Data Kitchen. Tell me about the problems that they're encountering and how specifically they are using Data Kitchen. And I don't say that as give me the pitch, but I think circuitously this will be a give me the pitch, because I want to understand how do you address the problems that they're having? I think the problems you're addressing are probably other also problems that a large startup like Airbnb or Uber, they're probably having problems in their data infrastructure that is not exactly the same as the giant insurance company, but probably reflective of some of the same challenges. So tell me about the customer landscape and the challenges they're having today.
Yeah. So in order to do that, I want to just talk a little bit. So we're a bootstrap company. We're about $4 million in revenue. We've been around for about 5 years, and we're going to continue to bootstrap. And one of the reasons is that to make a change in an organization, that 6 months to change a data warehouse, you've got to, partly it's like the Phoenix Project, you've got to change people's mindset a bit about how they work. And so in a lot of organizations, there is a partitioning of work. You think of this value chain of putting data in a database, having some schema, having a model and a visualization, but there may be 10 different roles, a dozen different roles in there between the person who does the schema design, the person who does the ETL, the person who does the QA, the person who does the visualization, the manager of them, the person who writes the requirements. And there's this giant team of people who all have kind of narrow skills. And organizations tend to want to have that the bigger they get, right? Because the narrower skills they have, it's easier to hire people who have one specific skills than someone can do everything. But that is a blocker, both in terms of people's fear of someone else taking over my job, but also the coordination cost of having to have all those people work together. And so that's a barrier culturally, and how to coordinate the team. And the B2C consumer companies, I think, are honestly, they're just better at it because they're younger companies, and companies like Spotify have built this idea of agile and hyper-empowered employees kind of into their DNA. And so that's something that I think people as consumer companies, I think, are better at than more traditional companies. But traditional companies have, from a business owner, they got money and they've got challenges. And it kind of sucks to be, I put myself in the place of those people, and it actually kind of sucks to work there, right? That you're kind of a smart person, you're trying to do what's right for the company, you've worked for the company for 10 years, and you're caught in a process that at the end of the day, having a half a page of code takes you 6 months to get into production. It makes you want to smack your head and quit and run away. But these are very valuable companies that contribute to our economy, and these people are smart people, and they want to find a better way. And so I see it as, in a lot of ways, the reason I'm doing this company in my 50s is these people are suffering in some ways. And they suffer because they're in a managerial environment that's tough. And a lot of companies are trying to be agile. They do sort of fake agile. Even in the data side, they'll have everyone do agile, some form of agile training. They'll make a special room with posters in and cool monitors, and they'll say, we're doing agile, right? And it's nice, right? They're doing agile, but they're really doing wagile or fake agile, where it's dev sprint, QA sprint. And it's not really quite there yet. And I think one of the reasons is the same reason that what happened in software is, you can do agile, but you really needed DevOps, deployment automation, test automation, infrastructure as code, those DevOps tools to really make Agile sing. And I think the same thing will happen in data and analytic teams, whether they're, data scientists or data engineers. They need some tooling to help them, and that's what we're trying to do is say, look, you got to get some tools to help you here. You can't just, it's necessary to do Scrum and Kanban and whatever flavor you want of how to organize your team, but the sufficiency comes from a technical environment that enables you to do it. And like you said, the linchpin of that technical environment is having a huge amount of automated tests that both function to monitor the data flowing through your system and to help you ensure that you don't break things when you deploy it into production.
And they have tools, but the tools that oftentimes the workflows that they build around are these ancestral, the really old pieces of software, and then it gets tied into the organization. And I agree with everything you said. I've gone to a number of conferences in the Kubernetes space, and they're making the same kinds of sales to these organizations, the insurance companies and so on, more from the infrastructure and just software application deployment and management space, and also how do we get these companies into the cloud? Now that they see the potential for the cloud, what is their road to the cloud?
Yeah, in the data world, they've got this, I'm running something in-house, and then my CIO has said, well, we're moving to the cloud and we're doing Agile. And from a data team, data analytics team, they're like, oh my God, how do I do that? How do I, it's taking me months to make a change to my data warehouse. Now you're asking me to move it to the cloud and start making changes to it on a weekly or even daily basis. And so that's a challenge that a lot of companies are facing because they know that their business customer is getting used to, it's the sort of Amazon model. Like one of our customers who runs a data and analytic team, his perspective is I'm competing with Amazon. And not because Amazon has a data warehouse in the cloud or Redshift, or not because Amazon is going to get into his business, which happens to be sort of healthcare. It's because it's the perception of his business customer that they can go click on a screen and get a box shipped to them the next day. And he feels like he needs next day insight to his business customers. And so he needs to be able to deliver new changes, new models, new visualizations very rapidly and high quality to his customer. And that's the world he lives in. He lives in an Amazon rapid response world. And so how do we get our teams of people to do that? And whether it's an ancient tool that is like Informatica or ETL, or it's a modern tool, it's not about the tool, honestly. And something I find frustrating in vendor pitches is this sort of way that they want you to trust that if you just do it in my tool, everything will be all right. And it really pisses me off going to conferences because the tools create code and that run in one of their engines or run in a VM, right? That's it. It's code. So how you manage that code, how you test that code, how you deploy that code isn't solved by buying a $3 million Cloudera license and all the tools that they've aggregated. It isn't, and every vendor is trying to go, the BI vendors are trying to do data science. The data science are trying to do data engineering and deployment. Everyone, these front end tools is trying to say, I do everything. And if you standardize on my tool, everything will be great. And that's just such BS. It's a multi-tool world and people are productive and can express their ideas in their tool of choice. And I don't ever want to get between an R and Python discussion with a data scientist or a Tableau and Click discussion in BI, and let alone trying to say if someone loves Airflow or someone is standardized on Informatica. People just love their tools, and the tools don't solve the problem. It's how you organize the people and the tools to do their work. It's your manager's problem. And as a manager, you need to sort of change your thinking of how you work with your team and stop blaming your employees, stop living in hope that you go to a vendor and everything's going to be all right, and stop the stupid sort of field of dreams kind of way of doing things. And it really gets me frustrated when I see companies actually do spend $2 million on a Cloudera license and then start pouring in little data sets. And then it's a year before any customer sees any value of that. And it's just like, that's an insane way to work. And then they no wonder why you read about data warehouse failures. Now you're starting to read about data lake and big data failures. And then now you're starting to read about data science failures. And all of it's because they're failing because they're not delivering value to their customers quickly. And it's not to say that you shouldn't short shift all the other stuff that goes with that aren't directly value driven, like architecture, design, data governance, documentation, training of your team, all that stuff. But you have to deliver. In order to be successful in the world, you've got to deliver in short cycle times, and you've got to have a mix of things that deliver value to the customer and deliver indirect value to the customer: infrastructure, documentation, governance. And instead of the waterfall way of, okay, we're going to spend a year on all the stuff that doesn't deliver value to the customer, and then magically everything's going to go. And it's a pattern I see in a lot of companies where they're spending a lot of money on vendors. They believe the tool is going to do it. They get all the tools in-house, and then lo and behold, the business user says, I spent $5 million on you guys in the last year and I haven't seen anything. and then, then they scramble, and then, hopefully they still have a job, right? And sometimes they don't, because the average tenure of a CDO is like 2 years now.
Cloud computing can get expensive. If you're spending too much money on your cloud infrastructure, check out Do It International. Do It International helps startups optimize the costs of their workloads across Google Cloud and AWS, so that the startups can spend more time building their new software and less time reducing their cost. Do It International helps clients optimize their costs. And if your cloud bill is over $10,000 per month, you can get a free cost optimization assessment by going to doit-intl.com/sedaily. That's doit-intl.com/sedaily. This assessment will show you how you can save money on your cloud. And Do It International is offering it to our listeners for free. They normally charge $5,000 for this assessment, but Do It International is offering it free to listeners of the show with more than $10,000 in monthly spend. And if you don't know whether or not you're spending $10,000, if your company is that big, there's a good chance you're spending $10,000. So maybe go ask somebody else in the finance department. Do It International is a company that's made up of experts in cloud engineering and optimization. They can help you run your infrastructure more efficiently by helping you use commitments, spot instances, right sizing, and unique purchasing techniques. This to me sounds extremely domain specific, so it makes sense to me from that perspective to hire a team of people who can help you figure out how to implement these techniques. Do It International can help you write more efficient code. They can help you build more efficient infrastructure. They also have their own custom software that they've written, which is a complete cost optimization platform for Google Cloud, and that's available at reoptimize.io as a free service if you want to check out what Do It International is capable of building. Do It International are experts in cloud cost optimization, and if you're spending more than $10,000, you can get a free assessment by going to doit-intl.com/sedaily and see how much money you can save on your cloud deployment. You've painted a bleak picture, and I can imagine this. Actually, I have no trouble imagining it. Like, I'm a giant insurance company. I pay for a large vendor. You've named a few. I can imagine a few others. The large vendor parachutes in with an army of consultants and a variety of expensive software with licenses, and they spend some time racking up additional consulting fees, hanging out at the insurance company, developing some workflows, giving some whiteboarding sessions, and then they leave, and a year later, nothing has really changed. It's not hard for me to imagine that. Can you contrast that with a happier path? So maybe something like, I mean, you're a vendor. Data Kitchen is a piece of software, but I think your idea is a little more agnostic. Your idea is, we're going to give you this tool, and it's going to slot into your existing workflow, and it's going to help you tack on additional workflows that do not disrupt your existing workflows. If I understand correctly.
Yeah, it's a little. So that's why we're bootstrapping, right? Because we're still trying to figure out exactly what the right way is to get organizations to move along this. And partly it's just sort of me talking to analysts and talking about this idea and getting the idea going in the world. But that's one part of it that we're trying to do. We're trying to be idea mavens, right? And the second part is working with customers. We're saying, you've got tools that do data science and ETL and visualizations. We're going to work with those tools. Don't replace those. And if you do, you want to standardize, fine. There's some benefit of that. But a lot of companies have 3 of everything already. And a lot of companies have set up different groups in the organizations to try to innovate or do Agile. So start small and then take those current tools and get a customer and get some data and start delivering values every week. And have that team work together and try to make their customers successful and only focus on the customers. Be relentless on that. Have your data engineers be empowered to organize the data, use the tool of their choice. If they like to code in Python or like to write SQL or use their favorite ETL tool, let them do that. And your data scientists and all of them are aligned and working to make the customer successful in a short cycle time. And have that group then work for 6 months or a year and start delivering real value. And then people will start to believe that this is a better way to work in an organization. And so we're on a try it, see it, have it work instead of the big bang. You've got to make a massive transformation to DataOps today. And that's the way we want to help people do it, by kind of showing and doing and starting small, starting cheap, as opposed to selling multi-million-dollar pieces of software. And it's a very kind of practical approach. It's not a VC, we're going to grow big and, grow 500% a year. We're growing, we grew 100% last year. We're growing probably 50 or 100% this year. But it's a slow and gradual way that we're going to try to help, make a little dent in the world and get these analytic teams to stop working in such a challenging way and really improve their life. And hopefully 5 years from now, it's going to be more accepted. And because when I used to be a software engineering manager in 1999, I thought it was pretty hot shit that I could get my team to ship software every 3 months. And now if I would go out and try to get a software engineering manager and say I could get my team to ship software every 3 months, I would not get a job because people would think 3 months is just way, way too slow. And that change in the world's attitude of how you deliver value fast, how you iterate and improve, how you innovate, and the set of ideas behind that are encapsulated in DevOps and lean manufacturing and Agile, I think need to become more accepted in the data and analytics world. And they're starting to. Like if you look at, I would love to get Netflix as a customer, but Netflix is awesome. They've got a bunch of open source. They build all their own tools. They're far ahead of a lot of companies are because data is their business, and empowering people to create ideas from that data is fundamental to their growth. And very non-technical people use that data as well. And so I think that's where we want to go, where lots of people in the organization are empowered to create artifacts from that data. They're empowered to share those widely in the organization, reuse those in the organization, and they can be changed quickly and deliver high quality data. That's the sort of vision that we're trying to do. And DataOps is part of that, but obviously not the whole thing.
Yeah, so you certainly don't have to sell me on the non-venture-backed model of what you're doing. I mean, I've been paying attention to indie hackers for a long time, and my business is bootstrapped, and if it's bootstrapped, then you can go more slowly with customers and with any aspect of your business. You understand the inputs and the outputs much more easily when you're bootstrapped. And also the economics of a SaaS business are such that you really don't need, you can have very high margins operationally. You pay an upfront expense for writing the code and developing the UIs and so on, and it's a one-time fixed cost, and it's like building a building that then replicates itself at very low marginal costs, and it's a great business model to build a SaaS business, even if it's a CMS that only 100 different enterprises use, and they pay you a couple $1,000s a year. Can be very good business. And I've seen on Indie Hackers a number of different CMSs and marketing tools and APIs that seem narrow, but they're good businesses. But all that said, I really want to understand the people who, you got $4 million in annual revenue, which is fantastic. So we've talked about some different concepts here that I can get behind data ops wise. We've talked a lot about testing, a little bit about version control, a little bit about tool agnosticism. I think there's some other elements of data ops that we haven't really gotten into, but I want to know specifically what kinds of tooling are you building into Data Kitchen? And when somebody becomes a Data Kitchen customer, what are they saying? This tool gives me the ability to do X more easily.
Yeah. So what we our ideal customer profile is a buyer who's is squeezed between their business customer who's demanding high quality data and insight rapidly. And they're failing at it, right? They're sort of getting beat up by their business customer. And then they really want to they hired a bunch of
And then, by the way, sorry to interrupt you, that would be like the VP of marketing. The VP of marketing is breathing down my neck to get these reports faster, and it's not happening, and they're upset at me.
Yeah, the VP of marketing, they want a segmentation, they want the reports, and last week you had a major data error, and he looked bad in the reports he was giving to his boss, and you've got a VP of sales, and you've got some operational people, you're a data organization, and you're failing to both deliver high quality recurring insight to your customer because of ongoing data errors, and you're not realizing what you really want to do with your team, which is create and innovate. And that's our ideal customer and we don't particularly care. We're a small company. We don't, we've got container orchestration system. We've got some open source APIs where you can plug in all these different tools. So we try to get people who have Tableau, try to get people who are on Amazon or have a certain set of databases, have a certain set of ETL tools that we've already integrated with. But in general, people, we're trying to get people who feel that pain pretty palpably, that I want to innovate and I can't. And man, I'm looking bad in front of my customer. and I have a CDO role and I can't sit with the other CXOs and feel, cool, basically, because I'm having all these embarrassing production problems, or like it takes me 3 months to update a database. And that's the kind of who palpably feel that they're not innovating and delivering value. And what we try to do is work with them and say, look, let's start small. Let's not replace everything. Let's take a subset of your customers, a subset of your data, a small team, and a set of tools, and we'll start iterating quickly. And once that happens, then customers say, oh, I'm starting to get new things every week from this team. I want to work with that team. Oh, I'm starting to get there's the trust issues between quote IT or the data science and engineers and the business customers break down. They start communicating. They start having their weekly scrums. They start trusting each other. And then when the development team says, you know what, these next 2 weeks, 80% of the work I want to do on some governance and documentation, and I want to refactor these 3 things, then the person says, yeah, that makes sense. I can see how that's going to help me, the business customer. And you get a good relationship going. And once that's repaired, the sort of us versus them, the rolling of the eyes of the business customer is repaired in a small way, then the entire organization can be transformed, because these are people, right? And you need to have the people work together in a different way. And not all organizations are like this. It's not all Hatfields and McCoys between the business customer and the data analyst. And I try to sell a bit in extreme. There's lots of companies that are really working well, but that's how we work. And our success has come from the end business customer, that VP of marketing, saying, I have a data set I can trust and I can try some stuff out, and I trust my team that's going to be able to help and support me. And I'm looking good because of it. And the chief data officer, chief analytic officer, head of analytics, head of data science, whatever their, the terms are, is then feeling empowered and wanting to try some things. And the conversations are less about, oh, we had a massive data error last week, and more about, hey, what about this new data set? And hey, can I heard about this way of looking at data with this tool. I want to try that out. And that's when things, from our perspective, people are starting to really see the value, and they become very hooked on our product, because it becomes easier to innovate and you've got just less stress.
And is that because it's good for communicating? Like, should I think of it like a Slack or a Asana kind of tool?
No, not at all. Actually, people use Giro. We like phone calls. What it really is a way to orchestrate. So if you take the typical value chain in analytics, the data engineering part, which could be code or ETL or Airflow or whatever tool, and the data science tools, which there's a lot, could be SAS or Python, and then visualization tools. Those tools all plug into our platform. And what we do in the operational sense is we inject the code that those tools take. We run that code, and then we pull out test information from that to make sure while it's running that it's correct. And so from a production standpoint, those are our stands, the ETL, those are the parts of the factory floor that the data flows through that we're running and monitoring. And so we orchestrate all that in a directed graph. We do it across clusters of machines. We use Docker, we use APIs, we even, bundled some DevOps tools working SSH into different machines and just lay the code on the machine and run it from the command line. And we also do some DevOpsy stuff to make sure the environment is set up to do that. And then the second part of what our tool does is we help deploy code into production. So we have this overarching thing that runs all these systems. We use a lot of food metaphors, like a lot of tools. So we have this recipe that we've decorated with tests, and we allow people to kind of, a little different than software development. The creating of your dev environment is actually a little bit harder in the analytics world, because you've got these really complicated directed graphs that have like hundreds and hundreds of nodes, and you want to run part of them, and you want to have a certain subset of test data, and then you want to have the right version of the Python library. So we kind of have wizards and tools to help create the dev environment quickly, and that's actually a surprisingly hard problem that a lot of companies have. A lot of companies they have either very rigid, here's the development environment, everyone has to use it, or they're doing stuff on production and hacking. the first thing when you go into a software engineering organization, you set up your dev box, and then you you run the unit tests, and then you make a change and you deploy a simple bug fix into production. And that's that's your first week in any software engineering job. And that's almost impossible to do in a lot of organizations if you're on a data science or data engineering organization, to make a change that couples across all these systems and deploy it. So we're trying to make it easy to do a development environment, and then easy to make a change, see if that's broken anything by running all your tests, having test data management, and then deploying it into production. And so that idea of orchestration of what happens in production, and a lot of analytic, we're starting to use the word continuous integration and deployment. I've shied away from it for a couple of years because nobody knows what it is in the data analytics world. Yeah, they're
okay.
They know about deployment. What deployment for a lot of companies is, I have a dev database, and then there's literally a Word document that's 10 pages long that talks about, okay, I get the code from this file system, or they might use Git, or they might have to get it from some other database. And then here's how I push that code into my UAT box to do testing. And then here's how I push it into production. And so deployment is really pretty archaic at a lot of companies. And that's why it does take 5 or 6 months to deploy anything.
I think I'm getting this. And I know we're basically out of time, but just a couple more things. In preparing for the show, I took a look at the product. I looked at some videos online, and obviously Nick connected us, and I trust his judgment. But frankly, I didn't really understand what the product was doing. But now this is a challenge for a lot of software companies, but explaining what their product actually does. But I think I'm hearing it from you now, and you can tell me if I'm wrong. But it sounds like, so continuous integration, continuous deployment, it's a little bit easier to understand relative to what you have to do for data, because in continuous delivery for just software, it's like a single pipeline. It's like a Trello board. You've got dev, test, like some sort of staging environment. You've got prod. You've got just these stages. And it's just like, this is where certain pieces of code is running. With DataOps, it may be a wider variety of dimensions. It's not just like one track that your code is moving along. It's like you've got different versions of models, you've got different data sets, you've got a wider array of environments that things can run. It's a more multi-dimensional. But the thing that you would like to be able to sell this product on the dimension of is, this is like continuous delivery. This is like continuous integration. But you don't want to use those words because the people that you're selling this to don't know what those words mean.
Yeah, that's the challenge. Yeah, that's the marketing challenge, right? Because part of our product's sort of like Jenkins. Part of our product's
like Jenkins, right?
Part of our product's like a test suite. Part of our product is an orchestration tool like Control-M or even like Airflow. And part of our product is a way for you to simplify creating a development environment that we call a kitchen. And all those things we've built because we've had to, because of been doing it for 15 years, because of these set of beliefs. And so that's where also why, it's great that we're $4 million in recurring revenue, but it's a struggle to express simply the varied value propositions and how we do it. And one of the things that I'm trying to do is say that DataOps is a thing. And definitionally, this is what DataOps is. It's a thing you should do. And you can buy our product, but you know what? You could probably do Jenkins and Airflow and write your own test suite and have a bunch of scripts and get DataOps. And that's cool, honestly. If people start doing DataOps and they roll it themselves, I'm happy with that, because my goal is to make that the set of ideas behind DataOps happen in the world, and the company's a vehicle to do it. And I'd like people to buy our software, but if they don't, they can. There's lots of other. And Nick Schrock has got another idea that's very DataOpsy, and I think there's other companies that are doing it, and we're starting to get some analyst coverage, and even Gartner's put it at the very toe of their hype curve, which is, believe me, exciting in a marketing sense. So people are starting to talk about it, but it's nowhere near being a big thing. But I just want it to be a little thing and then we can go from there.
Chris Bergh, it's been great talking to you. I understand your product better now.
Well, it only took 40 minutes.
And
okay.
I hear the marketing problem. I totally hear it. That is not straightforward. And I like the DataOps strategy of starting with a more abstract movement, and I think that'll build trust, and also it will lead to some sales. Interesting product, interesting to hear a story of a bootstrapped company. So I appreciate you coming on the show.
All right, yeah, thank you for your time and appreciate the opportunity.
GoCD is a continuous delivery tool created by ThoughtWorks. It's open source and free to use, and GoCD has all the features you need for continuous delivery. Model your deployment pipelines without installing any plugins. Use the value stream map to visualize your end-to-end workflow. And if you use Kubernetes, GoCD is a natural fit to add continuous delivery to your project. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale your infrastructure on the fly. GoCD agents use Kubernetes to scale as needed. Check out gocd.org/sedaily and learn about how you can get started. GoCD was built with the learnings of the ThoughtWorks engineering team, who have talked about building the product in previous episodes of Software Engineering Daily, and it's great to see the continued progress on GoCD with the new Kubernetes integrations. You can check it out for yourself at gocd.org/sedaily. And thank you so much to ThoughtWorks for being a longtime sponsor of Software Engineering Daily. We're proud to have ThoughtWorks and GoCD as sponsors of the show.
Wow!